As you finish, go ahead and bring them up here to turn them in so I can give you the paper for today. As you get this paper, go ahead and start filling out the table at the top. Is there anybody else that I'm waiting on form up for?
I'm on it. I'm sorry.
So the top section that I'm asking you to fill out is asking you for the perfect square. So you're taking the numbers that they give you and you're squaring them to get the number to go into blank. So 1 squared would be what? 1. 2 squared would be what? 4. 3 squared? 9. 4 squared? 16. So you should have those numbers in that first column. Okay. So finish working out the chart. When you finish, check your work with my answers on the screen there. So when I refer to perfect squares, I'm referring to these numbers here. Okay? They go on forever because if you did 21 squared, you would get a number. 22 squared, 50 squared, 582 squared. So perfect squares go on for infinity. Most of the time when we're dealing with perfect squares, we're going to be dealing with these smaller perfect squares. So this top part should be a review. So I want you to look at the number 20 here and tell me what are two factors of 20. One of them has to be in our perfect squares list. Find the biggest one that you can find that's in our perfect square list. That's the ones you filled in the blanks. Okay, 4 times what? So 4 times 5 gives me 20. Okay, so if I separate these, okay, the square root of 4 times the square root of 5 gives me the square root of 20. But will one of those simplify?
Yes.
Which one? 4. Do we know what the square root of 4 is? 2, right? Because we have it, if you didn't already know that, right? It's up here in my list. So the square root of 2, or the square root of 4, is 2. So I'm going to, instead of leaving it the square root of 4, I'm going to simplify it to 2 square roots of 5. So 2 times the square root of 5. Now let me ask you another question. If I multiply -2 times -2, or -2 squared, what answer would I get? I would get 4, right? Because negative times a negative gives me a positive. Okay. What if I did 8 and I did -8 and I squared it? What would I get?
Wait, what? 64.
I would get a positive 64 as well, right? So when I take the square root of something, I actually have 2 possible solutions. A positive 2 square roots of 5 in this case, or the -2 square roots of 5. Because if I took -2 square roots of 5 and multiplied it by -2 square roots of 5, I would get 20. So this is actually my final answer with the plus or minus in front of it. So look at the 300.
Wait, I don't understand that. How does that equal 20?
That doesn't equal 20. That equals the square root of 20, which we just simplified.
Yeah.
But if I took, so in your calculator, because all you have a calculator in front of you, okay, take 2 square roots of 5 and multiply it by 2 square roots of 5. What does it give you? Type it in your calculator just like you see it there. 2, then the square root symbol with a 5 underneath.
I got 4.47.
Right? You just did the 2 times the square root of 5. You didn't square it. You didn't multiply it by itself again. So 2 times the square root of 5 squared. So put it in parentheses and put the square, or just multiply it by itself again.
What was it? 2 times 4?
So if you put it in your calculator, I have to get my online calculator to boot up here. So if I take, first off, let me prove to you that they're the same thing as well. Okay, so the square root symbol is right here above the squared. So control squared will give me the square root symbol, and I put 20. Okay, and I'm going to put equals or enter. Okay, so if I do, two, didn't want to go back up there. Okay, so 2, and then square roots of 5. Do I get the exact same number? Yes. They are equal to each other. Okay, the other way I could put that in the calculator is like I was telling you this week, right? I can do, and I can have it tell me true or false. So 2 square roots of 5. Okay, it's going to tell me yes, they're the same thing. Okay. Now, if I take the square root of 20 and I times it by the square root of 20, I get 20. So if I do 2 square roots of 5 times 2 square roots of 5, am I going to get 20?
Mm-hmm.
Yes. So simplifying radicals is something we did. We saw them more. We did some with just numbers, but we saw them more with the variables underneath them. Okay. So back to question number 2 here. What are 2 factors of 300 where that one of them is, at least one of them is a perfect square? You want to pick the highest one that you can find in your list up there.
Never mind. 100.
100. 100 times what? So 100 times 3 gives me 300. So if I take the square root of both of those, which one can I simplify? 100. So what's the square root of 100? 10. So it's 10 times the square root of 3. The square root of 3 can't simplify. It's not a perfect square, so we're going to leave it underneath the radical. And it is plus or minus because if you take both negatives and multiply them, you're going to still get a positive answer. Okay. Now, number 3 is a decimal point. Put that one in your calculator. What does it give you? 0.5. This is the only one that I will allow a decimal on, is if there's a decimal in the answer. But notice, is this right here a perfect square?
Yes.
25 is a perfect square. It just is behind a decimal point. What's the square root of 25? 5. So, same thing. It just stays behind the decimal point. It was still a perfect square. So look at number 7. What do you notice about those two numbers? They're both perfect squares. So what is What is the square root of 36?
6.
What is the square root of 49?
7.
Okay, it still stays a fraction. You just simplify them individually, and it's still plus or minus. So it's plus or minus 6 over 7. Number 8. What's different about number 8 than any of the other ones that we've done so
It
far?
has a negative in front of it.
It has a negative in front of it, which means I'm only looking for the negative root. So this one is not going to have a plus or minus because I only want the negative root. Okay, so is 225 a perfect square, or do I need to find factors for it?
Perfect square.
It's a perfect square. So what's the square root?
15.
15. So my answer here is negative 15. Not the plus or minus because it has a negative in front of it. So that's the only answer that I want, is the negative version. So now let's look at numbers 10 and 11 real quick. Now, if we want to solve and figure out what the root is, it is the same process, because if I have something squared, how do I undo squaring something?
Square root.
The square root, right? So if I want to undo b squared, I have to take the square root of it. Because it's b squared equals a number, right? To get just b, I have to take the square root of both sides. So is 441 a perfect square?
Yes. Yes.
What's its square root?
21.
21. So my answer is what? Plus or minus 21. In your Go formative, I do not need the letter. Okay? But you do have to put the plus or minus. It is in the keyboard there, the little symbol keyboard that it gives you. Number 11. What's different about number 11? What do I need to do if I want to use the square root to simplify it?
It's backwards.
I need to make it look like this one, right? I need to get it all the way down to where it's just the square of something equals a number. So how do I do that? I've got to add 200 to both sides. Okay, so now I have m squared equals 200. Now can I take the square root of both sides?
Yes.
Yes. So the square root of 200, is 200 a perfect square?
No.
No. So what are my factors?
102.
100 times 2. So which one of those is the perfect square? 100. So I list it first just because I know it's the one I'm going to simplify and it's going to come out. So 10 square roots of 2 plus or minus 10 square roots of 2. Look at number 13. What do I need to do to get this down to the r squared all by itself?
You need to subtract 4 from each side.
Divide on both sides. Why do I divide instead of subtract?
Well, that's how you do it.
You need to get it by itself, but what am I undoing?
Because 4 is multiplying.
4 is multiplying, so I need to divide by 4 to undo the multiplication. Okay? So that gives me r squared equals 25 over 4. Just because I get a fraction, does that mean I can't do it?
No.
No, right? That just means break it apart. Okay? Does 25
Yes.
have a square root?
5.
5. Does 4 have a square root?
Yes.
Okay, so plus or minus 5 over 2. And one more, I'm going to let you work on them yourself. What about number 17?
You have to divide it and subtract or add.
Okay, what am I going to do first?
Divide. No, subtract.
Okay, we got to do PEMDAS backwards when we're solving because we're undoing it, right? So we're working it backwards, so we have to do PEMDAS backwards. So addition and subtraction have to be done first in order to undo. So we're going to add 1 to both sides. So we get 1/4 x squared equals 1. Now what? Do what? Divide by 1/4. Your calculator will divide by a fraction. Okay? So yes, divide by 1/4. If I divide 4 into 4, if I divide 1 into 4 equal groups, how many groups do I get? 4. Right? That's what you're doing when you're dividing by a 4th. Okay? So I'm going to have I have x squared equals 4. Square root of both sides, so plus or minus 2. So this assignment is not due until next week because it's today's assignment. You have the rest of the class period to work on this assignment or to work on an assignment from earlier this week that you need to get finished. Okay. I prefer if you have the paper copies, the ones from Wednesday and Thursday that you need to get to me, that you get working on those so you can get those turned in so I have the weekend to get them graded. Okay. If you wait till Monday to get them turned in to me, then I may or may not have time to grade them before grades are due. Go formative assignment from Tuesday, I will open up until Monday morning so that you will have the weekend to get those answers put in because those are easier for me to grade at the last minute than paper copies are. Okay. So the rest of the class period, you have time to work, which is only about 7 minutes.